Okay, let's get started with 13.5, the binomial theorem. Two objectives, we're going to evaluate n over j, and we're going to use the binomial theorem. So let's dive right in. So far up to this point, we have formulas for expanding x plus a to the second and to the third power. So you should remember these, that if we did this formula, a plus b squared, we get a squared plus 2ab plus b squared. And if we say a plus b cubed, and this is the one I've told you to memorize a whole bunch of times, and hopefully you have at this point, it's a cubed plus 3a squared b plus 3ab squared plus b cubed. All right, today we're going to figure out how to expand x plus a, or in this case a plus b, to any power up here. All right, so you'll notice here's to the fourth, x to the fourth plus 4ax cubed plus 6a squared x squared, etc., etc. So let's figure out how we do that, okay? All right, so the first thing that we're going to need to learn about is n over j, and this is exactly the same. So we're going out of order in the book. We've already learned how to do this because n over j is the same as combinations, NCJ. All right, so you'll notice down here the exact same formula from combinations, n factorial over, instead of r factorial, we're using the letter j here. Okay, not really important why, it's just a variable. Could use any letter there. We're going to say j factorial times n minus j factorial. So, just a quick refresher on this one. You've done this before. 3 over 1 is the same as 3c1, which would be 3 factorial over 1 factorial. And then 3 minus 1 is 2 factorial. And so you'd end up with 3 over 1, which is just 3, because the 2's would cancel out. This would be 4 factorial over 2 factorial, 2 factorial. Oh, got ahead of myself. So we'd have 4 times 3 over 2 times 1. That's a 2, so we'd end up with 6. 8 over 7, 8 factorial over 1 factorial, 7 factorial. That would just be 8. Everything else would cancel. 65 factorial over, in this case, it would be 50 factorial, 15 factorial, and on this one I would definitely recommend going to the calculator, which is right here, and just plugging it into our C function. So we can say 65 math, and we'll go over to probability and use NCR, 65 NCR 15. And our answer is quite large, 2.07 times 10 to the 14th. A lot of combinations there. All right, so just a quick refresher, try problem 5 and 6, and that'll just be a refresher of combinations. All right, so some things to throw into your notes. I'm not going to go through the proofs on all of these. Those are in your book if you want to take a look. But if you have a 0 in the denominator, not in the denominator, on the bottom here, right? You're taking 0 from a set. There's only one way to take 0. How many ways can you take 1 from a set? There's n ways to do that, okay? And if it's 1 less, it's n. So we saw that with 8 and 7 that we just did on the last slide. The answer to that was 8. And 8 over 8. How many ways can you take 8 items from 8? There's only one way for that to happen. So n over n is equal to 1. All right, so let's dive in here. This is Pascal's triangle. 0 over 0 is defined as 1. 1 over 0 is 1, as is 1 over 1. So you'll notice here 2 over 0 is 1, 2 over 2 is 1. The inside here, what you get to do is if you look straight above, if you add those up, 1 plus 1, you get 2. 1's always on the outside. 1 plus 2 is 3. 2 plus 1 is 3. Next row, 1, 1. 1 plus 3 is 4. 3 plus 1 is 4. In the middle, 3 plus 3 is 6. Now the nice thing about this is nice if you want to do a few rows, you could figure out the whole pyramid. But what if you wanted to do like the, I don't know, the third item in of row 84? Definitely you're not going to want to write 84 rows of Pascal's triangle. Instead, you're going to want to use 84C3 to figure out that number. All right, you may have noticed at this point that these are the coefficients of our binomial expansions. Remember that a plus b squared is 1a squared plus 2ab plus 1b squared. 1, 2, 1. That's from this row. If you remember a plus b cubed, you get 1a cubed plus 3a squared b plus 3, there's your 3 and your 3, ab squared plus 1b cubed. There's your 1 on the end. All right, so let's use this to actually expand any power we want. Here's the pattern. It's going to be n over 0, n over 1, n over j, n over n, all the way across. What that means is we want to do the second expansion, a plus b squared. We're going to start in the row. That's 2 over 0. That's also the row that has 2 as the second number in. If we want to do cubed, we're going to look for the row that has 3 as the second number in. A plus b to the fourth is going to be the row with 4 as the second number in. All right? As we go across, this is going to be 2 over 1. This is the second term. You'll have 1. The third term is a 2. If we go down here, the first term is 0, the second term is 1, the third term has a 2, the fourth has a 3, and the fifth term has a 4. Let's take a look at how this works. You're going to have x to the n minus 1, x to the n minus all the way down, and a's counting up. This is much easier to look at in an example, so let's do this. All right, x plus 2 to the fifth. Since this is to the fifth, that's not too bad. I'm just going to throw out the triangle real quick so we can use the numbers instead of having to use the calculator to find all of them. 4, 6, 4, 1, and 1, 5, 10, 10, 5, 1. All right, so this is the row of coefficients we're going to use. Here's how we're going to do this. I'm going to write out the coefficients. Give myself a little bit of space. After that, I'm going to write x in front of all of them because x is the first term of my binomial. After that, I'm going to write 2. And I'm going to put it in parentheses because we're multiplying. And we're adding all of these terms. Okay, so at this point, oh, I forgot my 2 on the end. What we need to do is we need to say, okay, we're being raised to the fifth power. We're going to start by saying x to the fifth. The next term, x to the fourth, x to the third, x squared, x to the first, and x to the 0. For the second term, the 2, we're going to count up from 0. So this is 2 to the 0, 2 to the first, to the second, to the third, to the fourth, and to the fifth. You'll notice that if you add the powers, the 0 plus the 5, the 1 plus the 4, the 2 plus the 3, they always add back up to 5. That's the setup. Let's just simplify. X to the fifth, 2 times 5 is 10, x to the fourth. 2 squared is 4, times 10 is 40, x cubed. 2 cubed is 8, times 10 is 80x squared. 2 to the fourth is 16, times 5 is also 80. X, and 2 to the fifth is 32. Okay. All right, that's your entire expansion of x plus 2 to the fifth. Now, this can seem a little tedious, but remember, this is much faster than having to go x plus 2 times x plus 2, foiling that, then using the box method to do another x plus 2, cleaning that up, then doing the box method again for x plus 2, and so on for the last one. You get the idea. This is much faster than doing the box method 5 different times. All right, let's do one more with 2y minus 3 to the fourth. So if we go back to the last slide, we're using 1, 4, 6, 4, 1. And let's throw in a 2y. To each term. And then we'll throw in a negative 3. Don't forget the negative. Almost there. Plus, and one more negative 3. All right, the pattern, 2y to the fourth. This will be 0. Third, 1, 2, 2, 1, 3, 0, 4. Simplify. 2 to the fourth is 2, 4, 8, 16. times negative 3 to the 0, that's going to be just 1. So you're going to have 16y to the 4th. Remember that the 4th power raises the 2 and the y. Negative 3 times 8, that's 24. 24 times 4, 96, not an equals, minus 96y cubed. This is going to be 9 times 4, that's 36. 36 times 6, what is 36 times 6? 3 times 6, 18, 216. This will be a plus 216. I forgot my, nope, y, sorry. 216y squared. This will be positive because negative 3 got squared. All right, this will be a minus. We have 27 times 2 is 54. 54 times 4 is 216. Also, is that right? Yep, 216 also. It's coincidental. And then lastly, negative 3 to the 4th is 81. 81 times, nope, just to the times 1. So we'll say plus 81. All right. That's the full expansion. Try problem 21 and 22. Sometimes you don't want the whole expansion, you just want a certain term. So we want to figure out what's the y to the 8th term in this. So remember on all of these, we're going to have the coefficients of n over j on each spot, and then we're going to have 2y to whatever spot we're in, right? So we'll fill this spot in here. And then we're going to have times 3 to the spot that we're in also here, okay? Now remember, as we go across, if this was a 0, then this spot right here would also be 0. If this spot was 1, then this spot would be 1. So these two spots are always going to match up. And the total, in this case this is going to be 10, you must have the total when you add up the powers. So if this was 1, this would have to be 9. If this was a 2, then this would have to be an 8. So let's figure out what we're dealing with here. So this is going to be 10 over, I want the y to the 8 term. Let's pause a second on figuring out what's going to go here. This is going to be 2y and a 3. All right, so it tells me I want the 8 right here, which means this must be a 2, which means I want the 2 spot right here. So let's figure out what 10C2 is from our calculator. Well, there you go. 10C2 is 45 times 2 to the 8th. 2 to the 8th, y to the 8th. 3 squared is going to be 9. So let's plug these all back in. 45 times 2 to the 8th. And then times 9. And we're going to have 103,680 y to the 8th. All right, that would be the y to the 8th term without having to expand the entire thing. Try one more. All right, so here you go. Here's the formula we just gave you. Let's do one more here, and then you'll finish up with a couple problems. The 6th term of x plus 2 to the 9th. So on this one, we know it's going to be a 9. Not sure about this spot. This is going to be x to the something, and this is going to be 2 to the something. Let's figure out what we're dealing with here. Now remember, if I said the first term, this would actually be a 0. If I said the second term, this would be a 1. So if I say the 6th term, this is actually going to be a 5. Since this is 5, this is a 5. And we have to add up to 9, so this must be a 4. So to the calculator we go, 9C5. And that is 126 times 2 to the 5th, which is 32. And 32 times 126 is 4,032. X to the 4th. That is the 6th term in this expansion. All right. 29 and 35 plus the even ones, yours to try. We are done here. Questions, make sure you're asking them in class. Good luck with all these problems.